Okay, hello, you're welcome to my channel. Now in this video, I want to answer this question right here, that if we have this integral, all right, the integral of 4e to the power x plus 6e to the power negative of x divided by 9e to the power x minus 4e to the power the negative of x, right, over the x variable is ax plus b times the logarithm of 9e to the power 2x minus 4 plus c, then we should find 10a plus 36b. Okay, we should evaluate this value given that this integral is of this form. Okay, so this is from one of the JEE indefinite integral questions, right? And one thing I noticed about these questions is that when you are given an integral like this, you should first of all look at the form you are given to present your solution as, right? If you are given this form, then you should try to make sure that your solution is of this form so that you can get the constant a out of it and then get the constant b out of it. The main question is this: what is 10a plus 36b? All right, so this will be wrong if you don't get this correctly, and you may not even get this if you don't have your integral in this form. So the form you are given is more important. All right, and then but the main thing we'll be doing here is to evaluate this integral. After evaluating, all this will fall in place if we do it the right way. Okay, great. So let's see what we have. So we have this integral here. I don't have much room, all right? So I'm going to start off immediately with the second step. Given that the first question, our question here is the first step, I'm going to say that we should multiply the top and bottom by e to the power negative of x, all right? When you multiply numerator and denominator by the same thing, it's just like you are multiplying the whole fraction by 1. So we haven't changed the integrand. So this means we are going to multiply the numerator by e to the power x, all right? Let me start the work here, e to the power x. And then multiply the denominator by the same thing, e to the power of x. So you notice at the top we are going to have this and that will go together. That means we're going to have e to the power 2x, right? Because they are just equal to each other, e to the power x, e to the power x. So you square that. And then plus, well, you notice this has a negative exponent of that. So we multiply them together. In fact, the exponent of e will just be 0, leaving us with just c, 6 times 1, right? And then the denominator is going to be, this times that will just be 9e to the power 2x. Right, and then we're going to subtract 4 from that, and then we put the dx over here. Okay, that's nice. From here I can decide to split the fraction, right, given that we have sum of terms at the top. So when we split the fraction, we're going to have this to be let me put this a little bit. This is going to be the integral of the first part, right, which is 4e to the power 2x divided by 9 e to the power 2x minus 4, right? And then we put the dx over here, and then we are going to add it with, well, the integral of, so this will now be this part, 6 divided by the same denominator, right? That's what we get when we split the fraction. You split the numerators when they are separated by an addition sign or a subtraction sign, and then you keep the same denominator for the both fractions, all right? So like this. Okay, and then we put them inside the integral sign as well, because the integral of the sum or difference is the difference of the integrals. So, okay, so this right here is the same thing as that from the indefinite integral properties. Good. So let's see. Well, we can evaluate this and that using different substitutions, or you can say change of variables. So here, okay, maybe let me do this. Let me call this something. Let's call this integral 1. All right, and then we call this integral 2. So we are going to evaluate this separately. So in fact, on this part of the board, let's go ahead and evaluate integral 1 on this part of the board. So we'll say we start with the integral 1, right? Good. So we have the integral 1 to be the integral of that. Well, I'm going to start by u sub for the integral 1. So I'm going to say let u, there's no point writing it out. You say let u be the whole of the denominator, right? So that will be 9e to the power 2x. Then minus 4. I want to make that my denominator. I want to make that my u. Okay, and when we do that, that means to differentiate, to get dx, you know, we have to do some derivatives on that, or some differentiations on that. So when we differentiate that, we're going to have the derivative of u with respect to x. What we are going to hold on that, that will be 18e to the power 2x, and then we can put the dx over here, right? So when you differentiate the exponential function, you differentiate the numerator, right, the power, sorry, and then you multiply it by the original function itself. Okay, great. Now the derivative of negative 4 is just going to be 0. So I want you to notice something here for the first part, right? want you to notice that we are going to bring this back into the integral. We are going to have the integral I1, right, to be, okay, let me just clean it up here. The integral I1 to be the integral of, well, let's just put down the numerator as it is, e to the power 2x divided by, now, this denominator, we call it u, right? We say u should be 9e to the power 2x minus 4. So in place of that, I'm going to put in u. And then dx, well, dx is going to be du over this, right? So it's just like we are going to divide this by both sides. So we're going to have, divide both sides by that, sorry. We're going to have this, 18e to the power 2x, right? So as you can see, some terms will cancel out nicely. 4 divided by 18 will just be 2 over 9, right? So that means this integral will become 4 over 18, which is 2 over 9 out front. Then the integral of 1 over u, right? And then we do that over the u variable. So in fact, this is going to be 2 over 9 times, well, when we integrate 1 over u, we just enter with the natural logarithm of u, okay? Or you call it ln u. And what is u in this case? Well, in this case, u is just that. So we are going to put in 9e to the power 2x minus 4 in place of that, in place of u, right? And this, in fact, is the first part of our solution because it's just what we call I1, right? So the first integral gives us this. I'm not going to add an arbitrary constant here because we are not done with the original, with the whole thing. So in fact, let me just call this one, the solution here to be 2 times that. So that will be 2 over 9 times the natural logarithm of 9e to the power 2x, right, minus 4. So as you can see, we already have something of that form, you know, logarithm. In this case, it's going to be to base e of that. So that means we have, since we have something of this form, we think we are on the right track, right? So we now have to evaluate this other integral, okay? So in fact, let me clean this part and then let's evaluate this integral and see what we have. Okay, very nice. Now let's turn on to the I2. Well, here I'm going to do a substitution. I'm not going to do the same substitution. I'm going to say let's make u. In fact, let's just use the variable u since we've cleaned it from this side, right? Let u, we start off by saying let u, all right, we be this term alone, 9e to the power 2x, all right? Maybe there could be other easier ways of evaluating this. We can use the secant substitution here, or maybe others, but I'll choose to do this one in this video. If u is 9e to the power 2x, that means we have to differentiate that, right? The derivative will give us, well, 18. I'll write the 18 this way. I'll write 2 times, let me put 9, right? 9e to the power 2x here, and then we can put the dx after that. So you notice this is the same thing when we differentiate just that, okay? But you notice that this term here, which is the 9e to the power 2x, is in fact equal to u. So we can rewrite this du as 2 times u, all right? And then we put the dx right there. So you notice that dx is going to be, this tells us that that dx will be, well, du over 2u, isn't it? So that's very nice. That means this integral I2, okay, will become the integral of 6. Maybe you can put the 6 out front since it's just a constant multiple, right? And then we have 1 over, well, this right here is called u. And then we subtract 4 from that. And then dx in fact is the same thing as du over 2u from this term right here. Permit me to do this. du over 2u. Okay, so we just have to multiply those two fractions together. And when we do that, we are going to have, well, 6 divided by 2, right? We are just going to have 3 at the bottom. And then we take the integral of, well, 1 over u minus 4, right, times this other u here. And then we can put the du right here. So we notice this. This right here can be resolved to its partial fractions, right, so that we can evaluate this integral. So in fact, let's look at what we get when we try to resolve this integrand, this 1 over u minus 4 times u to its partial fraction. So I'm going to do it right here, and then we'll just put the result back into the integral. So let's see. When we have 1 over u minus 4, right, we have that times u. In fact, we will have to write this in this way. Well, you put down the first fraction or the first factor, which is u minus 4, and then we put down the second factor, which is just u. You notice this is linear, that means the numerator must be a constant term. This right here is also linear, that means the numerator must also be a constant term. So I'm using AB to denote constant, just normal numbers, right? And if you like, you can just put the addition sign here for now. So what we need right here is to find out what the values of A and B are. The reason is we want to resolve this to its partial fraction such that the sum of these two smaller fractions will give us the bigger fraction. Okay, so what is the value of A and the value of B? Well, since this is just linear, we can make this use the cover-up method here. So you notice, see, this is how we're going to do it. We first of all question ourselves, what can we substitute for u in this denominator of A to make this denominator to become 0? So you notice if u is 4, this denominator of A will be 0. You come over to this main fraction, you cover up that particular factor u minus 4, and then you substitute u equals to 4 to the other term where you find u. That will be 1 over u. U is 4 in this case. That will be 1 over 4. In fact, that is just the value of A. 1 over 4. Let's do it again for B. This is B. For the denominator of this particular fraction to be 0, it means u should be 0. That's when the denominator will be 0. So you come over here, look at that particular factor u, cover it up, substitute u equals to 0 in the other term where you find u. So that will be 1 over 0 minus 4. That will be 1 over negative 4. So that means that's the value of B, negative 1 over 4. So that means this is going to be, if you can you can write this as 1 over 4 times 1 over u minus 4, right? You can say plus, okay, this is going to be minus. We got this negative sign here, minus 1 over u. Okay, so that if you multiply this back, you get this term, multiply this out, you get that term. So this right here is the partial fraction decomposition of this thing that we were given. So that means inside this integrand, I'm going to replace it with this. In fact, let's see, this is going to be 3 times the integral, right, of, well, let me put 1 over 4 here. We are going to have this term, 1 over u minus 4 minus 1 over u, right? And then we can put the du here. Very nice, isn't it? So let me clean this. Okay, very nice. Now let's see. This is going to be, well, 3 divided by 4, because 1 over 4 is a constant multiple inside, so we can just put it out front. Now we have to take the integral of 1 over u minus 4, right? Well, 1 over u minus 4, the integral will just give us the natural logarithm of u minus 4, right? Because the derivative of u minus 4 will just be 1. So when the derivative of the bottom gives us the numerator, then the integral will become natural logarithm of the denominator. Then we have minus. Similarly, the derivative of u is 1, so this will be the natural logarithm of u, sorry. Okay. Very nice. 3 over 4 out front. Now we need to get this back in its original variable. That means this is going to become 3 over 4 times, well, let me multiply it for everybody inside. That is the natural logarithm of u is this term here, 9e to the power 2x. 9e to the power 2x. So in place of u, we're going to put in 9e to the power 2x. And then we have minus 4 here, right? And then we say minus, well, 3 over 4 times the natural logarithm of u, where u is 9e to the power 2x, right? Very nice, isn't it? Okay, great. So this term is the integral of the second integral, that is the I2, right? But maybe let me rewrite it a little bit better so that when we plug it in here, it will maybe we are going to realize this immediately. So let's see. Well, look at this term. This is the natural logarithm of the product of two terms. When we have the logarithm of the product, is the sum of the logarithms. So this is going to be 3 over 4, right, times the natural logarithm of, see, this is clear. Okay, it's clear. Times the natural logarithm of this, let me just write it down, e to the power 2x minus 4, say minus. Now, the logarithm of the product is going to be the sum of the logarithms. That means we're going to have 3 over 4, then the logarithm of 9, right? Then minus 3 over 4, then the logarithm, or the natural logarithm of e to the power 2x. Good. So you notice, since this is a power, we can put it out front and multiply with the logarithm. And you notice that the logarithm of something to base e is just going to be that. Let me show you what I mean here. let's evaluate this. This is 3 over 4, right? Times 2x times the natural logarithm of e. So you notice when you take the power to back, that will become 2x. Then we have the natural logarithm of e is in fact going to be 1, right? So we just have this term 3 over 4 times 2x, which in fact is just negative 3 over 2. So this right here is going to be negative 3 over 2x, right? So you just check that out. Negative 3 over 2x, right? Very nice. Again, I'm not going to put an arbitrary constant because these are of two parts, right? This was the first part, this is the second part. We just have to add them together before we can now talk about the natural logarithm. So let me clean from here to this last line, to this second to the last line, so that we can just evaluate this at once and then answer the question immediately. Okay, so that means that the integral will become this particular integral, right? Okay, let me just write it down. Well, we are going to put this term here, which is 2 over 9 times the natural logarithm of 9e to the power 2x minus 4. Then we're going to add it with, remember it's plus, add it with, well, this term, which is 3 over 4 times the natural logarithm of 9e to the power 2x minus 4, right? And then permit me to put this term first. Say minus 3 over 2x, and then minus 3 over 4 times the natural logarithm of 9. And in fact, I'm going to add an arbitrary constant, and the constant is going to be, let's use C1. All right. Now, you notice that this right here, from here to here, is a constant, right? This is a number and then plus an arbitrary number. The sum of two numbers is a number. So this right here is, in fact, I'm going to call it capital C, right? But that is just by the way. From the first two terms, let's see. Notice that this right here is going to be just C, right? From here, I'm going to call that C. But the first two terms, you notice that this and that have something in common. That is the natural logarithm. So we just need to add 2 over 9. We have 2 over 9, right? Plus 3 over 4. Okay, since we have something in common here, which is 9e to the power 2x minus 4, right? And then we are going to subtract 3 over 2x from that. And of course, this is going to be plus c, okay, gotten from the sum of these two constants, where one of them is arbitrary. Good. So let's see how we can evaluate this sum. Well, for this sum, I'm going to multiply the top and bottom by something. Let me multiply this top by 4 and 4. I'm going to multiply this one by 9, right? Just, I want to add a fraction. So this is going to be 8, right? When you multiply 2 with 4, you get 8, plus 3 times 9 is 27, divided by, if you multiply this and that will be 36, and it's 36 for the two denominators, so we just maintain 1 of it, right? And you notice this top here is in fact 38 plus 27, which is in fact 35. So let me just rewrite the numerator as 35, right? We have 35. Then the natural logarithm of, we have e to the power 2x, right, minus 4. And then we have minus 3 over 2x, and then plus the arbitrary constant c. So this were equality signs. So this right here, this right here has that form, this form that we were given to compare with, all right, before evaluating this last question here. So you notice this is ax. Well, ax here can be called negative 3 over 2x, right? Then b times logarithm of that. So that will be this times the logarithm of that. You notice inside the logarithm, we have the same terms, and then plus the arbitrary constant c, which is gotten from the sum of these two constants, where one of them is arbitrary. Good. Great. So now we have to evaluate the main thing. Let me clean this part. The question now tells us to evaluate 10a plus 36b. So looking at comparing this our solution with the general solution that was given, we notice that a, so we say observe that a is, well, a here was the coefficient of x. The coefficient of x here is negative 3 over 2. What is b? B is the coefficient of this logarithm. So the coefficient here is just 35 over 36. So that means that 10a plus 36b 36b, right, is going to be, well, I'll multiply this by 10. We're going to have negative 30 divided by 2, negative 15, plus this times 36 will just be 35. In fact, this right here is equal to 20, right? This is what is required. So the answer to that question is equal to 20. Okay, so that was a lot, right? That was a question, but we made use of it already, so it's not really necessary. So this is how these questions appear, and thanks for watching, and please do well to subscribe to my channel. And if you like it and you want me to continue or do more questions on this, you put your comment in the comment section, and you let me also know what you think about this, right? Okay, thanks for watching, and see you in the next video.